Alright, so number one on the front side of the worksheet, you have a coin that's worth $1.17, and then it's increasing its value by 9% per year. For 5 years, you want to see the value of the coin in 5 years. So here is the principal, or the initial amount. Here is the increase, 9%, and the 1 represents the 100% that you start with. It represents this amount. And then here's the 5 years. So you combine these two, you get 1.09. Plug all this into a calculator. Just make sure you use the exponent key for this one. And you should get $1.80. So in 5 years, it's worth $1.80. For number two, you started off with a $1,500 in your account, and it pays 4% interest. So here's 0.04. The interest is compounded quarterly. So quarterly means 4 times a year, and that's why you have a 4 right here and a 4 right here. You want to know how much you'll have in 2 years, and that's where the 2's right there. You put this into a calculator, you get 0.01 plus 1 gives you 1.01. And then 4 times 2 is 8. Plug this into a calculator, and you get 16, 24, and 29 cents. Alright, so for number three, the initial amount is $12,000. Here's the one for the 100% that we start with. Here's the increase. The rate is 3.5%, so you always move the decimal 2 places to the left. This one is compounded monthly, so the 12 goes here and it goes here. And then this is for the number of years. Now notice here that I put ... because when you put this into a calculator and you add 1 to it, you get 1.0029 and more numbers. Okay, it doesn't end right here. So on your calculator, after you put this number in, just keep it on your screen. Do not delete it. Keep the whole number with all the digits. Now do the exponent to the 36th power, and then at the end just multiply by 12,000. Okay, and so what you should get after you do that would be 13,326 and 49 cents. It's a decimal right there, 49 cents. Number 4, they're asking you to determine the amount of interest earned on $2,500 at 5.25% compounded monthly for 4 years. So here's monthly, 12 and 12 for 4 years right here, and here's the interest in as a decimal. Okay, when you put this into the calculator and you add 1, you end up with this. Okay, 12 times 4 is 48, so that's why you have 48 right there. And then so you put this into a calculator and you get, let's see, you get 3,082 and 78 cents. Now the question is how much interest. So if you put in $2,500 and this is how much you have, so the interest would be the difference. So you take 30, 82, 78 minus 2,500, and so the interest would be 582, 78 in interest. Okay, so this is how much you've made in interest. For number 5, you have $100,000. You're going to put it in for 12 years at 5.2% interest compounded quarterly. So here you have the setup. You put this into the calculator and you get you get $185,000, 888 and 87 cents. So you subtract, in this problem you want the interest, so you subtract $100,000 from here. So when you subtract $100,000, you get 85,888 and 87 cents in interest. Okay, so that's the answer you're looking for here. So for number 6, you have $1,000 deposited into an account that pays 8% compounded quarterly. So remember, quarterly is 4 times a year. So that's why you have the 4 here and here. For 5 years, that's 5, and then this, you put this into the calculator and you get $1,485.95. So for number 7, notice I just put, because it's talking about the previous problem, like it's under this company, so this would be the same as this. Now the time, what's different is that it's 35 years, but the end, the 4 is still 4 because it's compounded quarterly. So you put this into a calculator and you get that. So they're asking for the interest, right? So if you put in $1,000 and after 35 years you have $15,000, so then the interest that you won is going to be $14,996.47 because you just subtract 1,000 from 15,000. So this is how much interest you have. Number 8, the house was bought for $96,000 and it's increasing 4% per year. It was bought in 1995, so they want to know the value of the home in 2007, so that's 12 years later, right? So you put that into a calculator and you get $121,000, 751. It looks like an 8, but it's a 5. 751. So for number 9, you start off with $500, investing at 4.25% compounded quarterly for 12 years. So here is the setup right here. Because you divide this is a 4 quarterly, and add 1 and you get this decimal. And 4 times 12 is 48, and this is what you get. Now they want the interest, so now I'm going to subtract 430.41 minus 500. So we get 330.41 as interest. Number 10, the initial investment is $300 in a 6 7.75% account, compounded semi-annually, so that's twice a year. And so in the exponent you have 2 times 20 because it's for 20 years. So you get this as this part right here after you put it in a calculator. 2 times 20 is 40, and then that's the initial amount. So after you put that in the calculator you get $1,131.73. So number 11, we have $110,000 for a condo in 2005 that appreciates 6% per year. What's the value of it in 2012, or what was it in 2012? So that's 7 years later. So that's why you see the 7 in the exponent. And you plug it out into a calculator and you get that answer, 165,399. Excuse me, 33 cents. For number 1, on the back of the page, you have a $1,000